had plenty of time now to work on this one. All right, so we got to find basically what we had for when we came in to for our entrance ticket today. Okay, let's knock out the easy two first. What is the domain of this function? Go ahead.
All real numbers except
X cannot be 3. Yep. Okay. All real numbers. X cannot be 3. Agree? Love it. What's the vertical asymptote then? X equals 3. Good so far. Okay, you want to do end or asymptote behavior first? End first? Okay, so my end behavior is as x approaches infinity, what does my function do? And as x approaches negative infinity, what does my function do? What do we got?
Zero from below.
For which one?
First
First one?
Positive.
At positive infinity, do we agree with 0 from below? Only one so far has agreed with you, just so you know. I'm hoping that other people are thinking. Well, let's do it then. Okay? Because it's going to be -1, right? Divided by, if we go to infinity, that's a big positive number, right? Okay? Does the -3 really mean anything? No, so it's just going to be a big positive number, right? And that big positive number is going to get bigger and bigger and bigger and bigger, right? So it's going to go to 0. Negative divided by a positive remains negative, right? So it's going to go to 0 from below. That's why I was hoping everybody was thinking still. Okay? What about the other one? 0 from above? Just because the other one was 0 from below, or?
I mean, that's what I was doing when I did it. That was what I did, but I didn't do that.
Okay, because that might work out, but that's not necessarily going to be every time. Okay, so let's do the math then. Okay, so if I send x to negative infinity, right? So now I got a negative ginormous number, right? -3 just means it's going to be even bigger, but still negative, right? So that's going to be a negative big number. Negative divided by a negative is positive, so that's going to go to 0 from above. Okay? Asymptotal behavior. As x goes to what? We're talking x though, right? So x is left and right, so it's not above, it would be from the right or from the left, right? Okay? They mean different things depending on what they're on. So like when they're in the, because f of x is like y, so when they're there, that means above and below. But when they're here with the x, then it's left and right. Okay, so we've established that we've got a vertical asymptote at 3. So let's come from the left. What's a number on the left side of 3? 2. Okay, we'll put 2 into our equation. And then well, we can extrapolate it because that would all be, anything on the left is going to have that same property, right? Okay. So -1 over, so what's 2 minus 3? Negative, right? So anything on the left is going to have a negative denominator. That's going to be positive, right? Okay, because a negative divided by a negative is positive. And that gap is going to get smaller and smaller and smaller and smaller, which means this purple fraction down here is going to do what? Get bigger and bigger and bigger, right? So it's going to go to positive infinity. Flip it over to the other side. Now we're coming at 3 from the right. 4, okay. Plug 4 in. It's going to be -1 on the top, right? But so really just anything over on that side is going to be positive, right? What? So it's going to go to negative infinity. Questions? It's a thinking man's class, or a thinking person's class, I should say. Think day. Think unit. Okay? Do that one. What do I do first? Then what? Okay. Then what? What do I get? Do we agree with x equals 3? Do we like x equals plus or minus 3? Because if I would do this a different way, if I would factor this side, then I get positive 3 and negative 3, right? Okay, so what's my domain? Domain. Vertical asymptotes. How many are there? 2. Can I write them as 1 or do I have to write them separately? Why? Because why? Why would I have to write them separately? Are they points though? They're what? So they're 2 different lines. Yep, because they're 2 different lines, I got to write them differently. Yep, or separately, I should say. Agree? Are we done? Are we done? Why are we done? That's all it told us to do, right? Okay. Didn't say we had to do end and asymptotal behavior on this one. Reading directions is smart. Okay? Especially on Friday's quiz. Okay? Reading directions is going to be very smart for you. Okay? Alright? This one. Now we gotta go. Now we gotta do them all. Okay? So, first off, what do we do? Set the denominator equal to 0. Okay? So, that is x squared minus 25 equals 0. So then that's going to be x squared equals 25. So x is what? Plus or minus 5. Domain. Vertical asymptotes. Which one do you want to do first? End or asymptotal? End? End first? What's logic telling us? Which one do you want to do first, positive or negative infinity? Positive. Okay. So if I put positive infinity into this problem, into this function, right? Okay. So I get a positive big number on top, right? Right? on the bottom, what do I get? A bigger number, a smaller number, or the same number, just minus 25? Much bigger or just a little bit bigger? Give me another chance. What are we doing with infinity on the bottom? We're squaring it, right? So I'm taking infinity times infinity. Okay? Which, fellas, always tell your companion that you love them infinity squared, right? Because you can't get any bigger than that, can you? Unless you infinity squared plus 1. Right? Okay? So that's going to be a super huge number, right? On the bottom. Positive or negative? Positive. And as the top gets bigger, what happens to the bottom? It gets bigger and bigger and bigger much faster, right? Okay? So a positive number divided by a bigger positive number. What's it going to go to? 0, right? Above or below? Below. Above. Yep. Huh? Negative infinity now. Logic's all the same, right? What's the only thing that changes? In this problem, what's the only thing that changes in this function? Is the bottom negative? Why not? Because you're squaring it, right? So the bottom stays positive, right? So the only thing that changes on this going to negative infinity is the top now is negative, right? Bottom stays positive. Because you're squaring it and then subtracting 25. Still a positive number. Yeah? So what's this one going to go to? 0 from below. Okay. Now we've got to add some total behavior. Right? Because there's 2 vertical asymptotes, 2 sides to each one, means I got 4 of those behaviors to do. Okay? Lock it in. Give me a number left of negative 5. Negative 6? Okay? So if I put in negative 6 there, right? What do I get? I get a negative number over a positive number, right? And that positive number is going to get closer and closer and closer to 0. right? So that's going to go to what do you got? Negative infinity. Come in from the right side. What's the number on the right side? Negative 4. Okay. So if I plug that in, that's going to give me a negative number on top, right? What about the bottom? Negative, right? It would be 16 minus 25, that's negative. So what's that one going to go to? Positive infinity. Left side of 5. Now I'm going to have a positive number over a negative number, right? Because it's going to be 16 minus 5. That's negative. So what's that going to go to? Negative infinity. What color? Blue. I didn't use blue. Right side of 5. 6. Positive number over positive number. Going to go to be honest with yourself. Is the math hard? No. What's hard about it? You got to think about it, right? But even if you break it down, is the thinking even that hard? No, it's not. Okay? You guys are making this out to be so difficult when really you just have to think and plug in one number into the function. And really, you don't even have to plug it in. You just got to know your numbers and if it's going to be positive or negative. Okay? All right? So, next step on this great journey is we got to do horizontal asymptotes. Okay? Now, for horizontal asymptotes, those are also going to be lines like vertical asymptotes. Tomorrow, when we get to graphing, those are going to be dashed lines. On our graph. The equations of them now are going to be, not y equals 0, pardon me. That's what we've had so far. The equations now are going to be y equals some number because they're horizontal. And there can only be one or none of them. You can't have two horizontal asymptotes. You can only have one or none. Okay? Now, the nice thing about this is that this all ties into the end behavior. So vertical asymptotes tied into asymptotal behavior. Horizontal asymptotes tie into end behavior. And how that is that this is what f of x is going to approach at the two infinities. So if I go back a slide here momentarily, at my end behavior here, we approached 0 from above and 0 from below. And we've done that all day Monday. We did that so far up to this point. Now we're going to be able to approach some different number. I'm going to teach you how to figure out what that number is. Okay? So, how we find degrees, or excuse me, how we find horizontal asymptotes is we compare the degree of the numerator to the degree of the denominator. What's a degree?
The exponent.
What kind of exponent? It's something more than that. I can't just say the exponent. What if there's two exponents? So what?
The large one.
The biggest one. Okay, the biggest exponent. Side note, what's the degree of just a number? So like 7. What's the degree of 7? No. What's the degree of 7?
Nothing.
Why?
There's one variable next to it.
There's no variable next to it. So it's...
It's what? It's 1. What? 0.
What? It?
I'm so confused.
I know, because you're just shouting out random numbers.
Yeah.
That's why I didn't acknowledge your 0. Okay? Alright? So because there's no variable on a constant number, the degree is 0. Okay? Now, if I'm going to compare two numbers, right? If I'm going to compare two numbers, what are my 3 outcomes? If I compare two numbers, only 3 possible outcomes. Bigger, smaller, or the same, right? One's either bigger, so top is either bigger, bottom's bigger, or they're both the same. Alright? So, here we go. If the top is bigger, there's no horizontal asymptote. So if top has a bigger exponent, no horizontal asymptote. If the bottom is bigger, y equals 0 is the horizontal asymptote, or the x-axis. That's what we've been dealing with so far. We've always had the bottom being the bigger degree. And if they're the same, then the horizontal asymptote is y equals a over b. And I get a and b from my lead coefficients. A is the lead coefficient of the numerator. B is the lead coefficient of the denominator. Okay. Get out your supplemental sheets, your extra sheet, whatever you called it, your cheat sheet, whatever you want to call it. Okay? So far on that sheet from Monday, you should have a space at the top for step number 0. We're still not there yet. Okay? Then you should have a step number 1, which says find the domain in any vertical asymptotes. Right? Then you should have a step number 2, which says find the horizontal asymptotes if possible. Well, that's always going to be possible. And so then what we're going to say is we are going to say check the degree. Or not so much check. No, let's compare. Not quite sure why it always, whenever I have to go to type and I'm recording, it always stops the recording. So let's say compare the degrees there. Okay? So if big is over small, no horizontal asymptote. If small is over big, y equals 0 is our horizontal asymptote. If it's same over same, y equals a over b, and I get a and b here from my lead coefficients of the numerator and denominator. Okay? Keep that sheet out, because we want to keep that next to us. We want to use that as a reference guide as we're going through. Well, let's go back into our notes now. Okay? And let's find us the domain, the vertical asymptotes, and the horizontal asymptotes of these two functions. Domain of the first one. We can do that one in our head. Domain of the first one. All real numbers, but x can't be -1. Vertical asymptote then. Got to compare degrees now. What is the degree in the numerator? 2. What is the degree of the denominator? 1. Top bigger, bottom bigger, same. Top is bigger, so that tells me there is no horizontal asymptote. Domain on the second one. Vertical asymptotes.
X equals 3, and then X equals -3.
Degree of the top. Degree of the bottom. Bigger, smaller, same. Same. So that means what? Okay, what's A? What's B? So that's going to be y equals okay. Had it been like this, if there would have been a 2 there, okay, then it would have been 6 over 2, right? So that would have, we just said y equals 3. Okay, we don't leave it unreduced. Okay, you can actually, if you can, but if it would have been like 5, let's say, then we would leave it as 6 over 5, y equals 6/5. Okay, fraction form. Okay, love it. Wow, you're playing it time. We can do this. We can do this. Love it. Hammer this out. Domain. Starts with all real numbers, right? What can x be? Starts with a T, ends with whoa. Nope. Just 2. Why just 2? Because 2 is the only thing that makes it 0. Alright, well, let's do it. X minus 2, quantity cubed equals 0, right? Right? What are you going to do first? Cube root everything, right? Right? What do you get left side? X minus 2. What do you get on the right side? 0. Vertical asymptote. Degree of the top. 1. Degree of the bottom. Y equals 0. Okay. End behavior. So big number divided by a smaller number. I'm going to go to 0 because that's my horizontal asymptote, right? Positive divided by a positive is going to go to 0 from above. From below this time, right? Or from above? Which one? Below or above? Why? Oh, yeah? So you didn't do the math. Because if you would have done the math, you would have said that if I put in a negative big number in there, right? Okay? So then that's going to be negative big number, right? So that's going to be negative. If I put a negative big number in there, that's going to be a negative big number, and then I'm going to cube it. What's the cube of a negative number? Remains negative. So what's this one going to do? It's going to come from above again. No? I'd love to say that every time, Mitchell, you have one's from above, the other one's from below, but that's just not the case. Okay? Don't even pack up. We have some total behavior yet to go. Plenty of time. So from the left, so that's like -1, or from like 1, right? So then that's going to be, what? Positive? Yeah. Right? Oh no, it's going to be negative. Because, right, we're going to be on the left, so the bottom's going to be negative, top's going to be positive. Yeah. Oops, I put positive infinity there. Right? Now, since you've all packed up, you have homework tonight. Okay? Which is kind of why I was telling you not to pack up yet. What? Yeah. Yeah. This just do on a separate sheet of paper. Okay? And then this one's a turn in. But you're going to turn it in like the entrance ticket. I'm not going to stand at the door and check it though. But you're going to turn it in as you walk into class tomorrow. Okay? Alright? Have yourselves a great, grand, and wonderful day.